Witam Was bardzo serdecznie w drugiej lekcji letniej Szkoły Języka Angielskiego, technicznego języka angielskiego z blogiem inżyniera.pl. Jest mi niezmiernie dzisiaj miło zaprosić Was do wysłuchania ciekawego tekstu na temat Lean Manufacturing. Czegoś, z czym spotykacie się na pewno na co dzień, może część z Was nawet pracuje bezpośrednio przy Lean, jesteście specjalistami do ciągłego rozwoju. Ciągły rozwój jest dość mocno wkomponowany w każde praktycznie przedsiębiorstwo w Polsce. Przynajmniej mam taką nadzieję, że jesteście nastawieni na ciągły rozwój. Warto poznać zagadnienia języka angielskiego, słówka z zakresu Lean Management. W takim razie zapraszam Was do wysłuchania bardzo ciekawego tekstu, a na koniec do przesłuchania słówek, no i oczywiście nauczenia się ich. Dzięki. Lean Manufacturing. Lean manufacturing or lean production is a systematic method originating in Japanese manufacturing industry for the minimization of waste within a manufacturing system without sacrificing productivity, which can cause problems. Lean also takes into account wastes created throughout overburden and investments in workloads. Working from the perspective of the client who consumes a product or service, value is any actions or process that the customer would be willing to pay for. Lean manufacturing attempts to make obvious what adds value through reducing everything else because it's not adding value. This management philosophy is derived mostly from the Toyota production system and identified as lean only in the 1990s. TPS is renowned from its focus on reduction of the original Toyota 7 waste to improve overall customer value. But there are varying perspectives on how this is best achieved. The steady growth of Toyota from a small company to the world's largest automaker has focused attention on how it has achieved this success. Overview. Lean principles are derived from the Japanese manufacturing industry. The term was first coined by John Krafcik in the 1988 article Triumph of the Lean Production System. Based on his master's thesis at the Mid-Sloan School of Management, Krafcik had been a quality engineer in the Toyota GM NUMMI joint venture in California before joining MIT for MBA studies. Krafcik's research was continued by the International Motor Vehicle Program and MIT, which produced the international best-selling book co-authored by James P. Wormack, Daniel Jones, and Daniel Ross, called The Machine That Changed the World. A complete historical account of the EMVP and how the term lean was coined is given by Holwett in 2007. For many, lean is the set of tools that assist in the identification and steady elimination of waste. As waste is eliminated, quality improves while producing time and costs are reduced. A non-exhaustive list of such tools would include SMART, value stream mapping, 5S, Kanban, the pull systems, Poka-Yoka, error proofing, total productive maintenance, TPM, elimination of time batching, mixed model processing, rank order clustering, single point scheduling, redesigning working cells, multi-process handling, and control charts for checking Mura. There is a second approach for lean manufacturing, which is promoted by Toyota, called the Toyota Way, in which the focus is upon improving the flow or smoothness of work, thereby steadily eliminating Mura through the system and not upon waste reduction per se. Techniques to improve flow include production leveling, pool production by means of Kanban, and the Heijunka box. This is a fundamentally different approach from the most improvement methodologies and requires considerably more persistence than basic application of the tools, which may partially account for its lack of popularity. The difference between these two approaches is not the goal itself, but rather the prime approach to achieving it. The implementation of smooth flow exposed quality problems that already existed, and whose waste reduction naturally happens as a consequence. The advanced claims for this approach is that it naturally takes a system-wide perspective, whereas a waste focus sometimes wrongly assumes this perspective. Both Lean and TPS can be seen as a loosely connected set of potentially competing principles whose goal is cost reduction by the elimination of waste. These principles include pool processing, perfect first-time quality, waste minimization, continuous improvement, flexibility, building and maintaining a long-term relationship with suppliers, automation, load leveling and production flow, and visual control. The disconnected nature of the sum of these principles perhaps springs from the fact that the TPS has grown pragmatically since 1948, as it responded to the problems it saw within its own production facilities. Thus, what one sees is the results of a need-driven learning to improve where each step has built on previous ideas, and not something based upon a theoretical framework. Toyota's views is that the main method of Lean is not the tools, but the reduction of the three types of weights: Muda, non-value adding work, Muri, overburden, and Mura, inefficiency, to expose problems systematically and to use the tools where the ideal cannot be achieved. From this perspective, the tools are workarounds adapted to the different situations, which explains any apparent incoherence of the principles above. Lean implementation emphasizes the importance of optimizing workflow through strategic operational procedures while minimizing waste and being adaptable. Flexibility is required to allow production leveling, heijunka, using tools such as SMET, but have their analogs in other processes such as research and development. However, adaptability is often constrained and therefore may not require significant investments. More importantly, all these concepts has to be acknowledged by employees who develop the products and initiate processes that deliver value. The cultural and managerial aspects of Lean are arguably more important than the actual tools or methodologies of production itself. There are many examples of Lean tools implementation without sustained benefits, and these are often blamed on weak understanding of Lean throughout the whole organization. Lean aims to enhance productivity by simplifying the operational structure enough to understand, perform, and manage the work environment. To achieve these three goals simultaneously, one of Toyota's mentoring methodologies, loosely called Senpai and Kohai, which is in Japanese for senior and junior, can be used to foster Lean thinking throughout the organizational structure from the ground up. The closest equivalent for Toyota mentoring process is the concept of Lean Sensei, which encourages companies, organizations, and teams to seek third-party experts that can provide advice and coaching. In 1999, Spear and Bowen identified 4 rules which characterize the Toyota DNA. 1. All work shall be highly specified as to content, sequence, timing, and outcome. 2. Every customer-supplier connection must be direct, and there must be an unambiguous yes or no way to send request and receive response. 3. The pathway for every product and service must be simple and direct. 4. Any improvement must be made in accordance with the scientific method, under the guidance of a teacher and the lowest possible level in the organization. Types of waste. Although the elimination of waste may seem like a simple and clear subject, it is noticeable that waste is often very covertly identified. This then hugely reduces the potential of such an aim. The elimination of waste is the goal of Lean, and Toyota defined 3 broad types of waste: Muda, Muri, and Mura. For many Lean implementations, this list shrinks to the first way type only with reduced corresponding benefits. To illustrate the state of this thinking, Shingo Observe that only the last turn of a bolt tightens it, the rest is just movement. This every finer clarification of waste is key to establishing distinctions between value-adding activity, waste, and non-value-adding work. Non-value-adding work is waste that must be done under the present work conditions. One key is to measure or estimate the size of this waste to demonstrate the effect of the changes achieved and therefore the movement toward the goals. The flow-based approach aims to achieve JIT by removing the variation caused by work scheduling and thereby provide the driver, rationale or target, and priorities for implementation using a variety of techniques. The effort to achieve a JIT exposes many quality problems that are hidden by buffer stocks by forcing smooth flow of only value-adding steps. These problems become visible and must be dealt with explicitly. Murray is all the unreasonable work that managers impose on workers and machines because of poor organization, such as carrying heavy weight, moving things around, dangerous tasks, even working significantly faster than usual. It is pushing a person or machine beyond its natural limits. This may simply be asking a greater level of performance from a process that it can handle without taking shortcuts and informally modifying decisions criteria. Unreasonable work is almost always a cause of multiple variations. To link these three concepts in TPS and Foslin, firstly, Murray focuses on the preparation and planning of the process, or what work can be avoided practically by design. Next, Murray then focuses on how the work design is implemented and the elimination of fluctuation at the scheduling or operational levels, such as quality and volume. Murray is discovered after the process is in place and is dealt with reactively. It is seen through variation in output. It is the role of management to examine the Murray in the processes and eliminate the deeper causes by considering the connections to the Murray of the system. The Murray inconvenience must be fed back to the Murray or planning stage for the next project. A typical example of the interplay of these wastes is the corporate behavior of making the numbers as the end of reporting period approach. Demand is raised to make plan, increasing Murray when the numbers are low, which causes production to try squeeze extra capacity from the process, which causes routines and standards to be modified or stretched. This stretch and improvisation leads to Murray-style waste, which leads to downtime, mistakes, and backflows, and waiting, thus the Murray of waiting, corrections, and movement. The original 7 Murrays are transport, moving products that are not actually required to perform the processing, inventory, all components, work in process, and finished product not being processed, motions, people or equipment moving or walking more than it is required to perform the processing, waiting for the next production step, interruption or production during shift change, overproduction, production ahead of demands, overprocessing, resulting from poor tool or product design creating activity, defects, the effort involved in inspecting for and fixing defects. Eventually, an 8 Murray was defined by Wormack in 2003. It was described as manufacturing goods or services that do not meet customer demand or specification. Many others have added the waste of unused human talents to the original 7 wastes. For example, Six Sigma includes the waste of skills, referred to as underutilizing capabilities and delegating tasks with inadequate training. Other additional wastes added were, for example, space. These wastes were not originally as a part of the 7 deadly wastes defined by Taiichi Ohno in TPS, but were found to be useful additions in the practice. In 1999, Geoffrey Mike in his book Kaizen Event Implementation Manual, added 3 more forms of waste that are now universally accepted. The waste associated with working to the wrong metrics or no metrics, the waste associated with not utilizing a complete worker by not allowing them to contribute ideas and suggestions and be part of participative management, and lastly, the waste attributable to improper use of computers, not having the proper software, training on use, and time spent surfing, playing games, or just wasting time. For a complete listing of the old and new wastes, see Biceno and Holweg, 2009. The identification of non-value-adding work as distinct from the wasted work is critical to identify the assumption behind the current work process and to challenging them in due course. Brought out in Smith and other process-changing techniques, really upon clear identification of where untapped opportunities may lie in the processing assumption are challenged. Lean implementations develops from TPS. Lean leadership. The role of the leaders within the organizations is the fundamental element of sustaining the progress of lean thinking. Experienced Kaizen members at Toyota, for example, often bring up the concept of Sanpei, Kohai, and Sensei because they strongly feel that transferring of Toyota culture down and across Toyota can only happen when more experienced Toyota Sensei continuously approach, coach, and guide the less experienced Lean champion. One of the dislocative effects on Lean is the area of the key performance indicators KPI. The KPIs by which a plant, facility, or judge will often be driving behavior, because the KPIs themselves assume a particular approach to the working being done. This can be an issue where, for example, a truly lean fixed repeating schedule and the JIT approach is adopted, because these KPIs will no longer reflect performance as the assumption on which they are based become invalid. It is a key leadership challenge to manage the impact of this KPI chaos within the organization. Similarly, commonly used accounting systems developed to support mass production are no longer appropriate for companies pursuing Lean. Lean accounting provides 3 Lean approach to business management and financial reporting. After formulating the guiding principles of its Lean manufacturing approach in the Toyota production system, Toyota formalized in 2001 the basis of its Lean management. The key managerial values and attitudes needed to sustain continuous improvement in the long run. These core management principles are articulated around the twin pillars of continuous improvement, relentless elimination of waste, and respect for people. Engagement in long-term relationship based on continuous improvement and mutual trust. This formalization stems from problem solving. As Toyota expanded beyond its home base for the past 20 years, it hits the same problems in getting TPS properly applied that other Western companies have had in copying TPS. Like any other problem, it has been working on trying a series of countermeasures to solve this particular concern. These countermeasures have focused on one culture, how people behave, which is the most difficult challenges of all. Without the proper behavioral principles and values, TPS can be totally misapplied and fail to deliver results. As with TPS, the values has originally been passed down in a master discipline manner from boss to subordinate, without any written statement on the way. Just as with TPS, it was internally argued that formalizing the value would stifle them and lead for suffer misunderstanding. However, as Toyota veterans eventually wrote down the basic principles of TPS, Toyota set to put the Toyota way into writing to educate the new joiners. Continuous improvement breaks down to 3 basic principles. 1. Challenge. Having a long-term vision of the challenges one needs to face to realize one's ambitions, what we need to learn rather than what we want to do, and then having the spirits to face the challenges. To do so, we have to challenge ourselves every day to see if we are achieving our goals. 2. Kaizen. Good enough never is. No process can ever be thought perfect, so operations must be improved continuously, striving for innovation and evolution. 3. Genchi Genbutsu. Going to the source to see the facts for oneself and make the right decisions, create consensus, and make sure goals are attained at the best possible speed. Respect for people is less known outside of Toyota and essentially involves two defining principles. 1. Respect. Taking every stakeholder's problem seriously and making every effort to build mutual trust. Making responsibility for the other people reaching their objectives. 2. Teamwork. This is about developing individuals through teams problem solving. The idea is to develop and engage people through their contributions to team performance. Shop floor teams, the whole site as team, and Team Toyota as the outset. Differences from TPS. While Lean is seen by many as a generalization of the Toyota production system into other industries and contexts, there are some acknowledged differences that seems to have developed in implementation. 1. Seeking profits is a relentless focus for Toyota exemplified by the profit maximization principles. Price minus cost equals profit. And the need therefore to practice the systematic cost reduction through TPS or otherwise to realize benefit. Lean implementations can tend to do emphasize this key measure and thus become fixated with the implementation of improvement concepts of or flow or pull. However, the emergence of the value curve analysis promises to directly tie Lean improvements to bottom line performance measurements. 2. Tool orientations is a tendency in many programs to elevate mere tools. Standardized work, value stream mapping, visual control to an unhealthy status beyond their pragmatic intent. The tools are just different ways to work around certain types of problems, but the way to not solve them for you or always highlighted the underlying cause of many types of problems. The tools employed at Toyota are often used to expose particular problems that are then dealt with, as each tool's elimination or blind spot are perhaps better understood. So for example, value stream mapping focuses upon material and information flow problems, a title built into the Toyota title for this activity, but is not strong on metrics, man or method. Internally, they well known the limits of the tool and understood that this was never intended as the best way to see and analyze every waste or every problem related to quality, downtime, personal development, cross-training related issues, capacity bottlenecks, or anything to do with profit, safety, metrics, or moral, etc. No one tool can do all of that. For surfing these issues and other tools are much more widely and effectively used. 3. Management techniques rather than changes agents has been a principle in Toyota from early 1950s, when they started emphasizing the development of the production managers and supervisor skills set in guiding natural work teams and did not rely upon staff level change agents to drive improvements. This can manifest itself as a push implementation of Lean rather than pull by the team itself. This area of skills developed is not that of the changes agent specialist, but that of the natural operations work team leaders. Although less prestigious than the TPS specialist, development of work team supervisors in Toyota is considered unequal, if not more important, topics merely because there are tens of thousands of these individuals. Specifically, it is these manufacturing leaders that are the main focus on training effort in Toyota, since they lead the daily work areas and they directly and dramatically affect quality, cost, productivity, safety, and morale of the team environment. In many companies implementing Lean, the reverse set of priorities is true. Emphasis put on developing the specialist, while the supervisor's skills level is expected to somehow develop over time on its own. Fourth, lack of understanding is one of the key reasons that a large share of manufacturing projects in the West fail to bring any benefits. In factory physics, Hoppe and Spearman describe this as a romantic JIT, where the beliefs in the method is more important than the actual understanding and results. In these aspects, lean manufacturing is more of a religion than a science. Others have compared it to the cargo called science. Steps to achieve lean systems. The following steps should be implemented to create the ideal lean manufacturing system. Design a simple manufacturing system. Recognize that there is always room for improvement. Continuously improve the lean manufacturing system design. Design a simple manufacturing system. A fundamental principle of lean manufacturing is demand-based flow manufacturing. In this type of production setting, inventory is only pulled through each production center when it's needed to meet a customer's order. The benefits of this goal include decreased cycle time, less inventory, increased productivity, increased capital equipment utilization. Continuous improvement. A continuous improvement mindset is essential to reach the company's goals. The term continuous improvement means incremental improvement of products, processes, or service over time with the goal of reducing waste to improve workplace functionality, customer service, or product performance. Lean is founded on the concept of continuous and incremental improvements on product and process while eliminating redundant activities. The value of adding activities are simply one, those things the customer is willing to pay for. Everything else is waste and should be eliminated, simplified, reduced, or integrated. Improving the flow of material through new ideal system layout and the customer required rate will reduce waste in materials movement and inventory. Measure overall equipment effectiveness is a set of performance metrics that fit well in a lean environment. Also, PMTS, methods time measurements, cost analysis, and perhaps time study can be used to evaluate the wastes and IT effectiveness in the operational processes. For example, Jung Ing Kerr and Yuhan Wang analyzed two prescribing technologies, namely no carbon required (NCR) and digital scanning technologies to quantify the advantages of the medication ordering, transcribing, and dispensing process in a multi-hospital health system. With comparison between these two technologies, the statistical analysis results show a significant reduction on process time by adopting digital scanning technology. The results indicated a reduction of 54% in queue time, 32% in order entry time, 76% in outgoing delay time, and 67% in outgoing transit time with the use of digital scanning technology. Teraz po polsku. Bardzo ciekawy tekst, mam nadzieję, że dla Was również interesujący. Dostęp do niego również macie, całego tekstu, na szkołę jakości.pl oraz również dostaliście go na maila. No i teraz z tego tekstu wybrałem dla Was 35 najbardziej przydatnych słówek moim zdaniem. Przejdziemy sobie teraz przez słówka, będę czytał po angielsku i po polsku, a Was proszę o to, abyście tych słówek się nauczyli. Będziemy się z nich przepytywać w niedzielę na spotkaniu na żywo. No to zaczynamy. Workload, obciążenie pracą. Adds value, wartości dodane. 7 wastes, 7 strat. Overall customer value, Ogólna wartość dla klienta. Lean Principles, zasady Lean. Steady Elimination of Waste, stałe eliminowanie strat. Mixed Model Processing, wytwarzanie różnych modeli, np. na linii montażowej. Single Point of Scheduling, jeden punkt planowania. Redesigning Working Cells, przeprojektowanie stacji roboczych. Pull System, system ssący. Control Charts, wykresy kontrolne. Waste Reduction, eliminowanie strat. Cost Reduction, redukcja kosztów. Long Term Relationship, długoterminowe relacje. Perfect First Time Quality, perfekcyjna jakość za pierwszym razem. Production Flow, przepływ produkcyjny. Unevennesses, nierówności. Non-Value Adding Work, praca nie dająca wartości dodanej. Overburden, przeciążenie. Simplifying the Operational Structure, ułatwianie struktury operacyjnej. Work Environment, środowisko pracy. Buffer Stock, bufor materiałowy. Material in Work in Progress, materiał w trakcie obróbki. Avoid proactively, unikać proaktywnie. Volume, ilość. Overproduction, nadprodukcja. Overprocessing, nadmierne procesowanie. Defects, defekty. Motion, ruch. Inventory, zapasy. Key Performance Indicators, KPI, kluczowe wskaźniki wydajności. Continuous Improvement, ciągłe doskonalenie. Decrease Cycle Time, zmniejszyć czas cyklu. Increased Productivity, zwiększyć produktywność. Increased Capital Equipment Utilization, zwiększenie wykorzystania wyposażenia. 35 słówek. Gdy weźmiecie słówka z drugiej lekcji, to będzie ich w sumie 70. Macie 7 dni, czyli 10 słówek dziennie i taką taktykę bym przyjął. Uczenia się 10 słówek dziennie i wtedy się nauczycie. Mówię poważnie. Więcej o tym, jak się uczyć słówek, znajdziecie w naszej grupie zamkniętej, gdzie macie dostęp jako kursanci. Też tam jest duża grupa osób, która się uczy, więc na pewno będziemy się wspierać w nauce słówek. No i zapraszam Was na spotkanie na żywo w niedzielę, gdzie przerobimy sobie te dwa zagadnienia. Lekcję pierwszą z zarządzania jakością i lekcję drugą z Lean Manufacturing. Dziękuję Wam serdecznie za dzisiejszą lekcję.